So today we are going to sketch the graphs of basic sine and cosine functions. Use amplitude and period to help sketch the graphs of sine and cosine functions. Sketch translations of the graphs of sine and cosine functions. And I'm not sure we're going to get to use sine and cosine functions to model real life data. I don't have all of the 4.5 notes, so I will finish 4.5 next week. All right, let's see how this sine function, all right, this sine curve here relates to the unit circle. So notice that we have sort of like an x and y axis here, or in their case they use t instead of x and f of t instead of y, but of course it's the same, right? They're just using t and f of t. All right, notice at 0, so that's referring to the 0 here in radians. So notice that you see that they have radians here and not degrees. So that's one thing you can notice. And here on the y-axis, or f of t, notice this is going to be your output for those radians. For example, at pi over 4, what is sine at pi over 4? What is sine? I'm asking y'all, what is sine on a unit circle at pi over 4?
Square root of 2 over 2.
All right, square root of 2 over 2. Very good. So that point here must be pi over 4, comma, square root of 2 over 2. What is the square root of 2 over 2 as a decimal so we can really break it down? Approximately, give me one decimal place. What is the square root of 2 over 2?
0.7.
So that sounds about right because that's 1 up here. This is 1 up here. So it's lower than that. So about 0.7. All right, let's go to some easier points that we can identify. All right, what about pi over 2? Pi over 2. What is sine pi over 2?
1.
1.
All right, so pi over 2, comma 1. That's the point. Now that one we can definitely identify because it's right there on that line. All right, let's see what's another good, easy point we can identify. What's an easy point we can identify? That's a nice and not decimals. Pi, yep, pi. Sine of pi equals what?
0.
0. So you see where the curve is coming from. So the input is pi, the output is 0 for sine. This is again the sine curve. And it's doing that for everything around this circle. That's why you're getting this curve action here. All right, what about 3 pi over 2? Sine of 3 pi over 2 is
-1.
-1. Okay. 3 pi over 2, -1. All right, good, because right here, sine is -1. All right, what about 2 pi?
0.
All right, 2 pi, 0. Input is 2 pi. That's why we have it sort of like on the x-axis, and the output is 0. That's sort of like on our y-axis. All right. But of course, we have some points that are not as pretty. For example, that at the bottom here, 5 pi over 3, comma, negative square root of 3 over 2. All right, so 5 pi over 3 is right here on the unit circle. And of course, our sign of that is negative square root of 3 over 2. All right, y'all tell me, what is positive square root of 3 over 2? Approximately. Give me two decimal places for that one. Two decimal places. What is the
Point
square root
eight
of
seven.
3? 0.87. Yep. Point. So square root of 3 over 2. Yeah, that's about right. All right. So do we understand where this curve is coming from in relation to the unit circle? Can you put a 1 in the chat if you get it? Where the curve is coming from? Okay. All right. Anybody needs you need me to break it down even more than that? Let's talk about some eventually what they're gonna say are some key points. Okay. So what are the x-intercepts on this graph? Right? Can anyone tell me what an x-intercept is on a graph from pre-calculus algebra or math 100 intermediate algebra on a
That's where
graph?
the
Uh-huh.
graph passes the x-axis.
Yes. All right. That's where it crosses the x-axis. So what are the x-intercepts then?
0. You want us to name like what a point
Say
is?
the point. Say the whole point.
0.
All right. A coordinate is a x and a y. Give me both. Give me both numbers.
I comma 0.
Pi
That's
comma
what you're
0.
saying?
All right.
Okay.
Yep. That's all right. And you probably saying it. I just want to make sure. So that's 0, 0. That's the x intercept. But do y'all recognize that's also a y intercept? Why is 0, 0 always both?
Is this the origin intercept?
Because it's in the middle.
Oh, mm, why? Keep on grasping for it. Why is 0, 0 an x intercept as well as a y intercept?
It's in the center.
Because they cross each other.
Cross each other? It's not what I want. I want exactly. Anybody else want to say why is 0, 0 an x intercept? Leo, you got any idea? Since you know where the x
Because it
intercept.
crosses the x and the y intercept at the same time.
Yes, y axis. Okay, y axis. It crosses the x and the y axis. That's a y intercept as well. All right, so that's an x intercept. That's an x intercept. All right, so 2 power 0 is an x intercept. Power 0 is an x intercept. 0, 0 is an x intercept. All right, the maximum or at the would be at or the maximum and the minimum would be at the peaks. All right, like at the top of the hill or the bottom of the valley. All right, so this is a maximum here, and this is a minimum. All right, and I have a note here. Note that the basic sine curve repeats indefinitely to the left and to the right. So whenever you see your graph going off the edge, that means it's going on forever. So let me emphasize that these functions go on forever in this direction, right? So notice here from left to right, it repeats indefinitely. So what is the domain of this function then if it goes on forever?
Infinity, comma infinity.
All right, all real numbers, yes. Therefore, the domain is all real numbers. All right, so I gave you that curve, and we're going to graph the cosine curve ourselves. All right, based on what we know about the unit circle. All right, so first of all, let's start with 0. Cosine of 0 is what? Cosine of 0.
0.
This is 0 right here, right? Well, how do you find the cosine on the unit circle?
Oh, it's 1.
Yes, it's 1. Okay. All right, what is another good radian we can use that's nice for cosine? It won't give us a complicated decimal. Give me another radian on the unit circle that the number is nice and whole.
Pi over 2
Pi over 2. Uh-huh. What is cosine of pi over 2?
is 0.
All right. Yes. All right. All right, let's go with, and y'all see definitely these at these quarters, the numbers are nice for both cosine and sine. So that the quarters, all right? So what about pi? Cosine of pi is
-1.
-1. What about 3 pi over 2? That's another quarter. Cosine of 3 pi over 2?
0.
0. What about cosine of 2 pi?
1.
1. Okay. And we're doing from 0 to 2 pi because the regular cosine and sine, they have a period of 2 pi. All right. Let's see if we can use any other points. No, that's good enough. All right, I'm going to attempt to draw it. It may not be good, but we're going to attempt to draw this. All right, so unlike sine, sine kind of started down here. Notice cosine is starting up here. So it's doing something like, all right, that's not good. And again, it goes on and on and on forever. Okay, that's just one period of cosine. All right, what are our x-intercepts?
Pi over 2,
What?
0, and 3 pi over 2, 0.
Okay. Pi over 2, 0. That's an x-intercept. 3 pi over 2, 0. X-intercept. Okay. What is our maximum points? Let's go ahead and do it. Maximum points.
0, 1,
Mm-hmm.
and then 2 pi over 1.
Oh, 2 pi 1, right?
I mean, yeah,
Maximum.
I'm sorry.
Mm-hmm. I get it. I say stuff like that. All right, 2 pi 1. All right, that maximum 0, 1 is also called a what? It could be also identified as what? 0, 1.
Y-intercept?
Y-intercept, yeah. It's also a y-intercept. It crosses the y-axis at 0, 1. All right. What about our minimum? What is our minimum?
Pi and -1?
Pi negative 1. So these graphs, sine and cosine, are different but similar because really, to be honest, one is just a shift of the other. But if you see it within this one cycle here, this one period, they're not the same, definitely. All right, any questions? So I found a graph that had both on them at the same time. So which one is sine, the red or the blue graph? Which one is sine?
Red.
Red. Red. Okay. All right. So y'all can get to see the difference between the two. All right. And again, it goes on forever. Make sure y'all know that. It doesn't stop. But when it goes right to the edge of the coordinate plane, whatever that indicates that it's going on forever. I think y'all know that by now from pre-calculus algebra. Right. It doesn't hurt to put some arrows on the end that we make sure we know. All right, so it turns out that the sine is all real numbers as we stated before. So all real numbers. All right. However, the range is not all real numbers. The range is on the y-axis. What is the lowest y value and what is the highest y value? Can anyone tell me what is the lowest y value and the highest y value for sine?
The
Highest
lowest
is
is
1 and
okay.
lowest is
Okay,
-1.
-1 and +1. Yes. All right. So it turns out that, yeah, for sine, it's always going to be between -1 and +1. So you could write it as range -1 to +1. -1 to +1. All right, the period, go ahead and tell you that's 2 pi for cosine and sine. So I think we already talked about period before. All right, 2 pi. Odd or even? Does anyone remember if sine was odd or even function? Forgot what section that is. Does anyone
Odd.
remember? Odd. All right, so that's section 4.2, I think here. If you go back, we talked about even and odd trigonometric functions. All right, sine is odd, but cosine and secant are the only even ones. Okay. All right, it turns out that the x-intercepts for sine is every, okay, let's see. Okay, sine, x-intercept. Y'all see that this first one was pi, then it's 2 pi here, x-intercept here, pi, and then another x-intercept would be 2 pi, but it continues on every pi. So it's going to be an x-intercept at pi, x-intercept at 2 pi, 3 pi, 4 pi, 5 pi, because it keeps on going on and on forever. So we're going to say every k pi, where k represents an integer, right? All right, so every half circle or half the unit circle, you will get the x-intercept. All right, the sine, notice, crosses the x-axis at its ends. So notice here, ends and the center. The sine function crosses the x-axis at the ends and the center. So let's write that down. Right, the ends and center of the period, and notice it peaks at the quarters. Quarters mean when you divide it into fours, right? So it peaks at the quarters. All right. But at the ends and the center, it crosses the x-axis, but at the quarters, it's either the highest amount or the lowest amount. Peaks at the quarters of the period. All right. Cosine. Let's talk about cosine. The domain. What do y'all think the domain is for cosine? Again, domain is this direction, right?
All real numbers?
All real numbers. It's going on and forever in that direction. The x's. All right? All real numbers. All right. Range. What y'all think the range is?
One and -1.
Still the same for that too. Notice the top is 1. Oh, the wrong one. And the lowest is -1. Same thing. All right. So same thing again. -1 to 1. Period. Still 2 pi. However, is cosine odd or even? Is cosine odd or even? From your notes from 4.2. Or from what I said earlier, if you caught it.
Even?
I think
Even. It is even. And odd, let me put this down. Just in case y'all don't remember. That meant that if you plugged in a negative x into the function, meaning you'll get negative f of x out. And even is if you plug in a negative x, you'll just get the original function back. Okay. For odd, plug in a negative, you get negative opposite of the function, original function. Signs, all the signs will change. All right, x-intercept for cosine. We got pi over 2. We got 3 pi over 2. All right, so it's definitely 1 pi over 2 plus another pi. So we have pi over 2, and it skipped to 3 pi over 2. So we added a whole pi. If you look at the circle, the unit circle, and we here, and we go all the way around here, we added a pi to that. Pi over 2, add a pi, you get to 3 pi over 2. All right. Therefore, the x-intercept, let's say it's every pi over 2 plus k pi. Again, where the k represents an integer. K could be 0 to start off with pi over 2. Then k could be 1. So pi over 2 plus 1 pi would be 3 pi over 2. And you keep on going on and on forever. All right. Notice that cosine, so in blue here, cosine crosses the x-axis. It's opposite. At the quarters, and it peaks at the ends and the center. So cosine is opposite of what we said for sine. It crosses the x-axis at the quarters, but it peaks at the ends and the center. So let's write that down. Cosine crosses the x-axis at the quarters of the period and peaks at the ends and center. All right, as a review for the sine function, let's go over some key points. Where are the intercepts, maximum points, and minimum points? All right, starting with 0 for sine. Give me an intercept. When sine is 0, we get what?
-1.
And sine is in red here, right? At
0,
0, 0, 0, 0, 0. That's an x-intercept, but it's also known as a what?
Y-intercept.
The
Y-intercept.
y-intercept.
All right. All right, give me another x-intercept for sine.
Pi and 0.
Pi 0. Give me another one.
2 pi 0.
2 pi 0. All right, notice those were my ends and my center. All right, let's talk about what's the maximum point for sine. Pi over 2.
Pi over
What
2,
else?
1.
1 maximum. All right, notice that that's at the quarters. All right, and 3 pi over 2, what is our minimum?
-1.
-1. All right. All right, for the cosine, I'm gonna let you try it. I want you to write down over here somewhere on your notes, what are the key points for cosine again? So write it out like we just did for sine. All right, I'm gonna give you 2 minutes to write it down. All right. So tell me, what is 0, 1? What is that? Where would you identify that as?
The x and the y-intercept. Just the y-intercept.
All right, 0, 1. Can anybody tell me 0, 1 is also known as a what?
The and.
Say it again, Trill.
The and. Yes.
Okay, it is the ends. What else?
The x and
Yeah.
y intercept.
Why isn't it? Let me look at it. Why isn't it? Okay, this is right here. Is it crossing the x axis?
Yes.
No. The
Oh,
x axis down here, right? So if it doesn't cross the x axis, it does not qualify to be an x intercept. Which axis does it cross?
y intercept. Y
It's a
axis.
y intercept, y axis. I'm still looking for another word though. What else is this not at the point
Oh,
zero
the
one is known?
max.
The max. Okay. That is a maximum point. Okay. Good. Maximum. Yes, it is. It is a y-intercept. 0, 1. All right. What about pi over 2 comma 0? That is a
X intercept.
hmm and notice for x-intercepts is when the y is 0. It's opposite of what you think it's supposed to be, right? X-intercepts when y is 0. That's why we set the function to 0 and 112 to find the x-intercept or the zeros of a function. Okay. Next point, pi over -1. What is that?
The
Identify
center.
it. Okay. What else?
The
It's the
minimum.
minimum as well.
Minimum. And 3 pi over 2 comma
X
0
intercept.
x-intercept and 2 pi 1 would be, did I put 1? Yeah, 1. for cosine, not for sine. Two pi 1 would be a what?
Maximum.
Maximum. Okay. All right, we're moving on. Any questions about intercepts, maximum points, and minimum points? They are referred to as the key points or the critical points in this section. So key points are the intercepts, the maximum points, and the minimum points. All right, let's talk about something called amplitude. Definition of the amplitude of sine and cosine curves. The formula is the absolute value of A. Where A are they talking about? They're talking about if you have a function that looks like this, the A is the number in the very front of sine or cosine. Sort of like if we had a regular function, not a trig function, we would call it a coefficient, right? So the A is the number in front of sine and cosine, and the amplitude is the absolute value of that. It tells us how high it gets above the x-axis and how low it gets below the x-axis. And they had some more fancy terminology in the book, but I changed it because I wanted to be simplified so that we can understand what they're talking about. All right, how high it gets above the x-axis and how low it gets below the x-axis in terms of its absolute value. All right, and then with period of sine and cosine functions, you can find the period if, let's just say, we're not dealing with the regular sine and cosine. The regular sine and cosine, we know what's going on. The period is 2 pi for both of them. Done. But what if these, we get some more complicated sine and cosine functions or other trig functions? Then we got to figure out what is one cycle of those functions. All right, so the formula for that is 2 pi over b. All right, so if you have something that looks like this, y equals a sine bx and y equals a cosine bx, b is the number in front of the x. All right, let me ask you this question. What would be the b considered to be in this one right here? What is b considered to be? Or what is b considered to be for this one?
Would it be X?
Let me say it again. It's the number in front of the x. So what is b?
1.
1. All right, if you don't see anything in front of the x, that's understood as a 1. So that's why for these, the period would be, for both, 2 pi over 1, which is 2 pi, which makes sense because the regular sine and the regular cosine both have a period of 2 pi. But as you can see, they're not always going to be like that, okay? One period of a sine or cosine function is one cycle of the sine or cosine curve, or where the trig functions repeat themselves. So this is just showing us what is one cycle. That period is just telling us this is one cycle, and then if you keep going, it just repeats that one cycle. Just sketch the graph of y equals 3 times sine x. All right. Let's first find the period and the amplitude first. All right, so usually I'm going to probably start off with period and amplitude. So period. The formula is 2 pi over b. So 2 pi over. What is b for this example?
1.
1.
1 again. Nothing is showing in front, so it's an understood 1 there. So the period is 2 pi. So we already know. Let's go ahead and put a 2 pi on our graph. That is, our cycle is going to end right there. All right, our cycle is going to end right there, our period. All right, and this is how we're going to divide up this graph. We're going to say, what is the half of this? What is half of 2 pi, y'all? What if we divide it by 2? What will we get?
Pi.
So we're going to estimate half the distance is probably right there. Okay. And then we need half of that. So what would be half the distance between pi and 0? So let's say the 0. What is half of that?
Pi over 2.
Yep. Then we got to figure out what goes here. All right. So we got to come up with a way to figure out what goes right there between that pi and 2 pi. We know it's halfway between those two. All right. One way you could do it is, if you know all of these are pi halves apart, right? So if you add another pi halves, you get pi. So you can add a pi halves to pi. So what is pi plus pi over 2? Y'all tell me. What is pi plus pi over 2?
1.
3 pi over 2.
Say it again, Trill.
3 pi over 2.
All right, because if you put a 1 here and then you multiply 2, you got it for fractions. That's why I put it on that first quiz. You're going to run into fractions a lot in this class, a lot. Right, so we have 2 pi plus pi, which is 3 pi over 2. Another way you could possibly have done that, and if I look at it, it's probably easier. You could, for this one, it would have been easier, added this, like average these two things. So how do you average something? How would you average? How do you average anything? What is the formula for averaging something in math? All right, Trig, I know we know how to find the average or something because we've been in school long enough. Nobody remembers? So if I gave
Wait, so you
you,
said the average of 2 pi. Wait, say that again.
how do you average numbers?
Oh, you add it all together and divide by the total number?
Thank you. Thank you, Leo. All right. So, and we only have two numbers I want y'all to average. Pi and 2 pi, for example. What are we doing to average that? What do we do with
You
pi and
divide
2
by
pi?
2?
What we got to do first? What we got to do first?
Oh, add them.
Add them together.
Add them. Okay. Okay. We got to add them first, right? All right. Let's see. So, for example, if we had to average those, then we would do pi plus 2 pi divided by what number? Leo, you already see. What number? 2, right? So that's 3 pi over 2. So we, either way, which one y'all like? Which way? The first way?
One.
You got the first one? Okay. Okay. Fine with me. As long as we get the right numbers. Okay. All right. So we spread it apart. We got our one period down. And let's go over amplitude. Again, that's the absolute value of A. And what is A in this case? Okay. Again, y'all see what we got up here. What is A in our case?
3.
So this not hard at all, is it? Absolute value of 3 is 3. Does everybody understand what absolute value means? I maybe I make sure everybody understand what absolute value means. Are we good? Does anyone not understand it so I can explain it? Okay.
Yes, please.
So you want me to explain it, Derica?
Yes, please.
All right. So on a like a regular number line, let's say we have 0, and that was -5, and that was 5. Okay. If we said the absolute value of 5, what would be the answer, somebody?
5.
5. Okay. Now, what if I ask you, what is the absolute value of -5? But what about the absolute value of -5? Anybody? Come on, y'all. Maybe yeah, maybe it's more than you, Derica. What is it, Jasmine?
Would it be 5?
It would be 5. Does anyone know why? That's what I got to explain to Derica. Does anyone know why it's just 5?
Because it's still 5 away from 0.
Because the absolute value represents distance from 0. Very good, Owen. All right. The absolute value represents that, right? Hold on. Value represents the distance from 0. So the distance from here to here is the same distance from here to here. Distance is positive always. So let's just say I ask you, how many miles is it approximately from here, from Birmingham to Tuscaloosa? What would you say? If we drive into Tuscaloosa, how many miles is that approximately, you think? Anybody got a clue? Anybody, you frequent Tuscaloosa? That was my old stomping ground, I guess. Maybe y'all don't know. All right. So let's just say it's 60 miles. But if you're in Tuscaloosa and you're coming back to Birmingham and I ask you how many miles it is approximately, you wouldn't say -60 because you're going backwards. It's a distance. So the distance is always positive. You're not going to change the sign of it just because you're going in a different direction. All right. Let's move on. So the amplitude again represents how high or above the x-axis and below the x-axis. All right. So let's put on here 1, 2, 3, 3. I'll try to do this even apart, but it may not work. And let's put -3 down here. All right. Now we know for sine, where does sine cross? Where does sine cross the x-axis? Does anybody remember? Where does sine cross? Sine crosses the x-axis where?
It says 0, 0.
All right, let me write it down again. That's all right. That's all right. Remember, we passed that page. Let's put it back on this page. This might be the last time I write it, though. All right, sine crosses the x-axis at the ends and center of the period and peaks at the quarters.
Oh, okay. I thought you meant like the point. That's my bad.
Oh. Oh. What did you tell me? You mean like, well, never mind. Whatever you said, you might have been right for what you thought I meant. All right, so sine crosses the x-axis. So the ends are here at 0, 0, 2 pi. Those are the ends. Which radian do you think is considered the center? Because that's how we start off this graph. Which one is the center? Out
Pi.
of this right here. Pi. All right, pi. All right. We're going to put another, because it crosses at the ends in the center. And we learned that it peaks at the quarters. So the quarters would be this and this. All right. In between those. So the amplitude we've learned is 3. And we're going to verify this on a chart somewhere. So, well, hold on. Let's go ahead and do that before I do that. Okay. Let's take a look at regular sine x. I need to write this down. Sine x, regular sine x, without that number in the front. What is going on at pi over 2? Sine of pi over 2 is normally what at the regular, original sine function. Sine pi over 2, what is the output for sine pi over 2?
1.
1. That's what we normally get. And then so we also want to know where the point is for 3 pi over 2. For regular 3 pi over 2, what is the output? Sine 3 pi over 2 will give us
-1.
So for this new function here, y equals 3 times sine of x. Wouldn't it just be, since this is your y, wouldn't this affect our y? Wouldn't it just be we multiply 3 times our output? Here's our output here. So if we multiply 3 times our output, we're going to get pi over 2. Let's just multiply this times 3 right here. We'll get 3. So 3 pi over 2. We'll multiply that by 3. We get -3. All right. But again, it told us that it was going to, our amplitude is 3. That is, and again, by definition of the amplitude, that's going to be how high it's going to get above that center line, whatever that center line is. And for us right now, it is the x-axis. All right, so let me erase this. So for pi over 2, we're going to apply 3. And for 3 pi over 2, we're going to apply -3. Now, I don't know how accurate my graphs are going to be, but I'm trying my best to curve it like it's supposed to, but that wasn't that bad. All right, again, this goes on forever and ever in both directions. All right. What is our maximum point?
Pi over 2, 3.
Okay. Pi over 2, 3. Maximum. What is our minimum point?
Three pi over 2, -3.
All right, 3 pi over 2, -3 minimum. What are our x-intercepts? You can give
Pi
me
0
one.
and 2 pi 0.
Okay. You said pi. Say it again. Pi 0? Okay.
Pi
Pi
0.
0. Yep. Anybody else? Trill gave me one. Somebody else gave me another one.
2 pi.
All right. 2 pi 0.
0.
X-intercept and 0, 0. And I may not write it every time, but that's also known as what? 0, 0 is also known as what?
Y-intercept.
Mm-hmm. Mm-hmm. All right. Let's try another one. All right. Sketch the graph of y equals -4 cosine x. All right. Let's find the period first. What is the formula for the period? To find the period.
It's 1.
What's the formula? Just give me the whole formula.
2 pi over b.
2 pi over b. I'm glad I'm asking y'all because y'all slow to tell me. So maybe I need to repeat it a little bit more. 2 pi over b.
1.
Okay, that's what you're telling me. Okay. So we got 2 pi. Let's go ahead and, all right, 2 pi. All right, if we have 2 pi, cut it in half, we get what?
Pi.
Half of 2 pi. Pi. We half that. What's the half of that?
Pi over 2.
Pi over 2. And then again, that would be what?
3 pi over 2.
3 pi over 2.
3 pi over 2. How do you get that? Then
Average.
that you can
We
average
add
what?
Pi and
pi.
2 pi.
All right, y'all saying two different ways. So Michaela, you say your way first, and then Detrill say his way.
Average it. So pi plus 2 pi divided by 2.
Okay, great. And Detrill, what is your way of doing it that you like the best?
That was the same way.
Oh, that was the same way. I thought you liked the other one, the first way. Remember?
The first way, yeah.
The first way is to add pi over 2 to pi.
Mm-hmm. Oh, I'm sorry.
She said add pi and 2 pi and then divide by 2. I think that's okay. All right, great. Now, let's just go ahead and do the amplitude. I don't know why my colors are not working right now, but okay. And what's the formula for amplitude?
Absolute value of A equals
Absolute value of A, right? And what is A in this case?
-4.
All right, so what is the absolute value of -4?
4.
All right. All right. So what do we know about cosine and its normal behavior? Cosine crosses the x-axis where? At the, anybody remember? I'm gonna go ahead. Quarters of the period. All right. And peaks at the ends and center. Cross the x-axis at the quarters. So that means that pi over 2 and 3 pi over 2 would be the quarters. And it peaks at the ends and the center. So let's think about regular cosine x. So the points that we did not plot are 0, pi, and 2 pi. So for the original cosine x, when we have 0, what is cosine of 0?
0.
Cosine of 0. Look at the unit circle.
Is 1.
Now that's blurry.
Yeah.
1 is correct.
1, 0.
For cosine of 0, what do you get for the output? Which one is it? 0 or 1? Leo? You said it right.
1.
Say it again. Okay, 1. All right. So for pi, cosine of pi, what is the output?
-1.
-1.
-1. And for 2 pi?
1.
1.
0.
Is it 0 and 2 pi? Aren't they the same spot, y'all, on the unit circle?
Yes, ma'am.
Look at it. Yeah, I want y'all to get very. That's why I'm glad I think this test is a good idea for y'all to get familiar with this unit circle here. 0 and 2 pi. That's why they got 0 right here and 2 pi right here. Because you start out with 0, and when you get all the way around, you end up with 2 pi, but you end up in the same spot. All right. All right, so if we have y equals -4 times cosine x, this part right here is going to affect our output, because whatever our output was, we're going to multiply it times -4. All right, so we're going to multiply this times this number, the output, times -4, not the input. All right, so instead of a 0, 1, what will we get? 0 what?
4.
What is it?
-4.
-4. All right. Instead of pi -1, we will get
4.
And for 2 pi 1, instead of that, we will get 2 pi -4. All right, let's plot that. So at 0 right here, we're going to get -4. So we're starting down here. Might be too low. All right, and then for pi, we said 4. And then for 2 pi, we said -4 again. So it's doing something like, go too far, because that's supposed to be the maximum. Like this. But again, it goes on and on forever. Notice that originally cosine x is, I said I was going to go through Desmos. So y'all should, well, I can do it. But notice that -4 from PreCalculus gave us a reflection of the regular cosine x. So I guess I can do Desmos now. So are you all familiar with Desmos? I know some of y'all are, because y'all been in my class before. Or is it GeoGebra? If you've been in Mr. Ross's class, you're probably familiar with.
Is it GeoGebra?
GeoGebra?
GeoGebra.
GeoGebra? GeoGebra? Say it, Detroit.
GeoGebra.
GeoGebra. I like that. GeoGebra. Okay. You sure that's how you pronounce it?
So,
All right. So let me put in the chat. All right. Desmos.com or G GeoGebra. GeoGebra? GeoGebra? Uh, all right. But Desmos.com is a free app. This is your graphing utility. Okay. I'm gonna pull it up. And we're gonna compare some graphs.
I have a question.
Uh-huh.
So you just basically take the x-axis, whether the cosine or sine crosses, and you just multiply by whatever the equation gives you.
All right. Say it again, Michaela. You just take the what? Say it again. I'm trying to understand your question.
So you keep using the cosine and sine when it crosses the x-axis and everything. You take those points and you multiply by whatever the equation numbers give you.
All right, the ones that are not, because we know if it crosses the x-axis, right? We know those points is at zero.
Yeah.
So all the other ones we kind of want to make sure verify that
I'm
it
basically saying
is.
like the points, like the y's and the points, if you get what I'm saying.
Yep. I just can't
Mhm.
change my color, Michaela. I wanted to change my output value so y'all can see we just multiplying -4 times that one, -4 times that -1, and -4 times that +1. That's
Yeah, I
what you
just see
mean?
the pattern. That's why I asked that.
Yeah. See on earlier where I had the sign, see how I had it in blue?
Mm-hmm.
1 times that 3, -1 times that 3, but I can't change my color for some reason. I was trying to drive that point home, but something's weird is going on with that. Oh, that gave me purple. But y'all very familiar with the regular one. But then let's compare -4 cosine x. Hmm. So obviously it reflected. Obviously. All right. Uh, but even the amplitude, the height of it is definitely more than 1. Again, is at 4, the maximum and minimum points. Or if instead of 1, 1, 0, 1, and -1. And sometimes it actually gives y'all the radians. If y'all can touch it, if y'all have touch screen, y'all can click on the actual points with your fingers. But sometimes it actually gives you the radians like this one, pi -1, right? And sometimes it doesn't. It gives you the number, right? But that's kind of cool that you can use Desmos to help you all out with your homework assignments. All right. Let's try regular sine x. Uh, and let's try 3 sine x. Look at that, and then we're going to take a break. Okay. Uh-oh. I didn't do that right. All right. Regular sine x is in purple. So did it reflect in this case? For the first example we did, was there a reflection? Was there a reflection across the x-axis? And how do you know when it is a reflection or when it's not a reflection? Does anyone know? Okay. So the
Is it
number
because
in the
it has
front,
the same points?
say it again.
Is it because they have the same exact points?
No, reflection really is indicated by that negative sign in the very front. So for a sine here, we didn't have a negative sign. So there's no reflection. But let's say I put negative 3 sine x and took out the positive 3 sine x. Y'all definitely see the difference now between the two. All right. One, they're not going in the same direction. You see what I mean? One is flipped. All right. So if we do positive 3, they're in the same positions basically. Just one is higher than the other. One is at 3, amplitude of 3 instead of 1. Versus if we put a negative 3 sine x, trying to choose another color, then y'all see that it actually flipped on us, kind of going in opposite directions. All right, moving on. But check out Desmos or GeoGebra. Detrail, how do you say it? You say it in a fancy way.
GeoGebra.
GeoGebra. GeoGebra. You put more emphasis on the Gebra. Okay, gotcha. GeoGebra. All right, stop sharing. All right, what's the formula for period?
Two pi over b.
2 pi over b.
2 pi over b. The question is, though, what is this
X
b?
over 7.
Think about it again, what we said earlier. All right, period. Anybody else? Any other guesses? What did I say b was earlier? Let me write it down.
The number.
The number.
Is it 1?
So what is b then? Do it again. Y equals a sine bx and y equals a cosine bx. B is the number in front or attached to x. So for this first one, what would be b?
X over 7.
It's not the x. Notice this. The x is not the b. X is its own thing. What over 7?
Is it 7?
1 over 7.
1 over 7. Thank you. 1 over 7. This is the same thing as 1/7 x. Y'all get that, right? X over 7 is the same thing as 1/7 x. Do we see it?
Yes.
Yes. All right. I don't think I had another example like that before. Okay. So 2 pi over what?
1 over 7.
1 over 7. How do we work this out? How do we work it out? Got a fraction again.
Do you put the 2 pi over 1?
2 pi over 1. Not necessarily. You could. I don't think it will affect it. So you saying how 2 pi over 1? It wouldn't affect it, but if you want to. Okay.
So it would be 2 pi over 7?
That's a 1 right here now. Y'all see the 1, right?
You multiply 7 over.
All right. Yes. All right. Let me write it all out because we got to get real comfortable with fractions in this class. So I'm not going to do this all the time because I want, as trig students, I wanted y'all to be kind of good at fractions.
All right, so 2 pi, this is really 2 pi divided by 1 over 7, which is 2 pi times 7 over 1. What is that?
14 pi.
14 pi. Okay. Amplitude, absolute value of A, and A is what here?
8.
Is it? Say it again. Maybe I missed it. I missed some of it. Say it again.
1 over 8.
1 over 8. A is the number in front of sine or cosine. So that's 1 over 8. So the amplitude is 1/8. All right. Yeah, don't miss these. These are the easier problems. Don't miss because you don't understand fractions. Okay, so try to get down fractions down. All right, the graphing is the one that you got to really think about. Let's try the next one. Find the period amplitude. So I'm going to give you 2 minutes to work on this one, where it's -4/7 cosine 14 pi x. Let's see what you do with it. That is 2 pi over b equals 2 pi. What is b? That is the
14
question.
pi.
14
14
pi. That's what I wanted to see if y'all put the whole thing. 14 pi is everything in front of the x. Correct. Now we got to work this out. All right. The x's can, the pi's can cancel. And then leaving us with what? If we reduce it.
1 over 7.
1 over 7 is correct. All right. Let's go to the amplitude. Amplitude. Absolute value A. Absolute value of what?
Negative 4 over 7.
Which equals?
4 over 7.
4 over 7.
4 over 7. Done. All right. So I did see some problems. That's why I screenshotted right from where it was signed that I didn't want you to trip up because it is easy when you think about what A is and what B is. All right. Let's graph again. This moved since I converted it to a Word document. All right. Okay. Let's start with period. I always start with that. So period equals 2 pi over what? Say it again.
3.
2 pi over 3. All right. So let's put 2 pi over 3 down here. 2 pi over 3. Now this one is different. Okay. What would be half of that? How would you find half of 2 pi over 3?
Is it pi?
How would you, is there a formula that y'all have that I can write down? How can you cut that in half?
Divide by 2.
Yes, just divide it by 2. That's what it means. Cutting in half means just divide it by 2. So what is 2 pi over 3 divided by 2?
Out pi over 3.
Very
1 pi over
good.
3.
Very good, Deandra. All right. 2 pi over 3 divided by 2 is 2 pi over 3 times 1/2. That cancels pi over 3. Just in case somebody needed to see that. All right. And then we got to halve that. So half of this, I need to figure out what is this right here.
Pi over 6.
All right. pi over 6, pi over 3 divided by 2. And this is kind of cool. We have something like this, you could just multiply that, but I'm gonna write it all out. Pi over 3 divided by 2 is times 1/2, which is pi over 6. All right, then we gotta figure out what's in between these two. How are we gonna do that?
Pi over 2.
Pi over 2. How you get that? Very nice. How did you do it that time?
I just looked at pi over 3 is 2 pi over 6, and 2 pi over 3 is 4 pi over 6, and it's in between. So.
You looked at pi over 3 as 2 pi over 6, and you looked at what? Say it again.
2 pi over 3 is 4 pi over 6.
4 pi over 6. And then you said it must be between 3 pi over 6. I like that.
Yes, ma'am.
I like that. All right. Anybody did it? I like that. Anybody did it a different way? I just want to make sure y'all got it. We know how to get this pi over 2. And one other person explained it another way to get pi over 2.
You add pi over 6 plus pi over 3.
Okay. Let's see. Because we know all of these should be pi over 6 apart from each other. So that's pi over 3 plus pi over 6. I need to multiply. I bet y'all didn't think fractions was going to be showing up so much in trig. Y'all thought y'all passed fractions, didn't you? Yeah, I know it. Y'all like,
Would be
I have to deal
nice.
with, huh?
It would be nice.
And y'all said, ooh, I don't have to deal with fractions anymore. I'm intrigued. Sorry. I'm rude awakening. All right. Very good. And then we know amplitude is this absolute value of A. And in this case, A is what?
1.
1. Mm-hmm. Okay. We know that the sine crosses the x-axis where? Where does sine cross the x-axis again?
Ends and center.
Ends and center. Ends. What did we say was the center again? What did we say was the center? Because my drawing is a little off. Doesn't look like the center, but it's supposed to be the center, y'all. What is the center? Which radian is the center?
Pi over 3.
Pi over 3, yeah, it's supposed to be. It don't look too much in the center, but it's supposed to be in the center. All right, very good. And we know that the peaks are going to be in the quarters. All right, and this is a positive sign. It's not negative, so we know it's not reflecting. So it's going to do the normal thing that we think it's going to do. It's going to do, we're thinking doing that. It's going to be up here and it's going to be down here. That's what we're thinking. But let's verify it. We can always verify by plugging in some points. All right. So for example, let me do like a little table. For all the points that, let's say we were unsure about. Let's say that was X, and we want to know at pi over 6 what's going on, and at pi over 2 what's going on. Now the function is f of x or y equals sine of 3x. We could, if we wanted to, plug in that pi over 6 right here. Okay, sine of, and let's clean it up. What is 3 times pi over 6?
3 pi over 6.
3. Okay, and what is that? 3 pi over 6 reduces to
A pi over 2.
Pi over 2. Mm-hmm. And what is sine of pi over 2? Sine of pi over 2.
1.
1. All right. So we were right about this one. All right. Y equals sine of 3 times pi over 2 is sine of what? What's 3 times pi over 2? 3 times pi over 2 is simply what?
3 pi over 2.
3 pi over 2. All right. Now we got to figure out what is sine of 3 pi over 2.
-1.
-1. So we were right about that too. It's down here somewhere. So it is doing something. Do my best here. It needs to be curvy. Like that. But going on and on forever. Consider one period beginning on the y-axis. Determine the 5 distinct key points, intercepts, maximum points, and minimum points. I kind of wanted to go over this because sometimes Web of Science asks y'all for the smallest x value and the largest x value. And I want to make sure you knew what was going on with it. Okay. So in terms of intercepts, they want to know x-intercepts. Okay, which out of the intercepts, it doesn't necessarily be x. It doesn't necessarily be x. It could be y. All right, out of the intercepts, which one has the smallest x value? Because we have 3 intercepts on this graph.
0.
0.
Okay, so that's 0, 0. Then what would be the next one in order? And then we're going to put the largest one.
Pi over 3.
All right, pi over 3, 0. And I like what Owen did earlier. He was like, this pi over 3, then that pi over 6 is like 2 pi over 6, and then 3 pi over 6, and 4 pi over 6. If you look at it like that, 2 pi over 6, 3 pi over 6, 4 pi over 6, you know they have the same denominator, so you know which one is bigger than the other. All right, but obviously we're going in order here. So, and then we'll have 2 pi over 3 comma 0. All right, and the maximum value is what? What is the maximum value?
Pi over
Pi over
6.
What else? Maximum point. All right, and then minimum.
Pi over 2.
Pi over 2.
-1.
Pi over 2. Okay. -1. Pi over 2, comma, -1. All right, great. We are moving on to this one. This one I put in here because it was a little different. It had that negative in there, and I wanted to address it right quick. Trying to see, can I? Okay. So, is cosine an even function or odd function? So that's why I kind of want to emphasize that at the beginning. Is cosine even or odd?
Even.
Yes. All right, so that means that cosine of any negative x is the same thing as cosine x. Or in other words, f of negative x is just positive f of x. So in that case, since the cosine function is even, then f of x equals, since cosine, then cosine of negative 2x would just equal cosine of 2x. So we're going to work with f of x equals cosine of 2x. It's the same thing. All right, y'all tell me what the period is. So I'll give you 30 seconds to work on the period. All right, what is B?
5. Wait, 2.
2. Okay, give me nails. I got you. Therefore, the period is pi. All right. So let's put pi here. What is half of that?
Pi over 2.
Pi over 2. What would be half of that?
Pi over 4.
Pi over 4. What would be between pi over 2 and pi?
Pi over 4.
3 pi over 4. All right. All right, give you time to get the amplitude. Give you about 20 seconds to work on the amplitude. What is A?
1.
All right. And we know that amplitude represents how high it is above the x-axis and below. So that's kind of telling us where our peaks are. All right, for cosine, where does cosine cross? Cosine crosses the x-axis where? Normally. Cosine crosses the x-axis at the
0,
what?
0, the center and the ends.
Cosine?
Oh, the x-axis and the cord. Hold on. Cosine cross the x-axis at the quarters of the
Uh-huh.
period.
Uh-huh. Okay. Where are the quarters?
Pi over 4, 3
Okay.
pi over 4.
Okay, great. And it's gonna peak everywhere else, right? So what we're thinking is that it's doing peaking. It's not a negative cosine on the very outside, so we're thinking it's doing that. But let's verify it and make sure we're right. All right. So verify. So for the points we didn't plot, let's just create a table. The points we then plot 0, pi over 2, and pi. And let's just plug it into the function. See what's going on. Y equals cosine 2 times 0 is cosine of what? Cosine of 2 times 0 is cosine of?
Two.
Huh?
0.
0. Cosine of 0 is
1.
1. Thank you. Y equals cosine of 2 times pi over 2 now. How can I clean it up? What's happening? What can I do right here?
Cross the twos.
Cancel. So really we end up with cosine of pi. What is the cosine of pi? Cosine of pi.
-1.
Y equals cosine of 2 times pi. It's cosine of 2 pi. What is cosine of 2 pi?
One.
1. All right. So where we write? Well, for 0, we get 1. Pi over 2 is -1. Pi is +1. So it's doing a little something like, and it's going on forever and forever. All right. If I ask you for, I think y'all got it. We're going to move on. Okay. Any questions about that one? Maybe we'll do one more from beginning to end. Maybe, yeah. Let's just do this one right here. This -2 sine of x over 8. And we'll end here. All right. So definitely I have not finished. I got to add some more notes. So just know that I'm going to add more notes by Tuesday. Okay. So what I want you to do now, I want you to take 5 minutes. Again, find the period, find the amplitude, and I want you to plot the points on the x-axis and the y-axis. All right. All right, let's see how it went. Okay, let's see. The one thing that kind of stood out is that negative in the front. I kind of want y'all to know that means it's gonna reflect, okay, when we get to the end. All right, so period. 2 pi over b. What is b? What is b? Y'all tell me.
1/8.
1 over 8. So when you did your calculation, what is the period? Anybody?
16 pi.
Yep, 16 pi. So that's where we're going to put here, 16 pi. Now we have that, have it. We end up with what?
8 pi.
8 pi. And then we have that. We end up with what?
4 pi.
4 pi.
4 pi. 8 pi. You think it's between 8 pi and 16 pi?
8 pi.
What'd you say?
Would it be 8 pi?
We got 8 pi right here. I'm saying what would be between 8 pi and 16 pi?
12 pi.
12 pi.
12 pi. All right. Hit start there. Let's do, we're going to amplitude. Okay, so that's absolute value of A. Absolute value of what number? What is A?
-2.
So the absolute value would be 2.
-2.
Oh, yep, which will be absolute value that would be 2. All right, so that's 2. That's -2. Okay, doing good so far. Sine crosses where? Sine crosses the x-axis where again?
The ends in the center.
The ends. I got that. Y'all got to help me out with that center. Which one is the center?
8 pi.
8 pi. Still doesn't look like it on my end, but mine's a little cricket. All right. And then normally sine, we go up, right? But we got a reflection here. All right. So it's going to go opposite of what we think it's going to go. So let's plug in some numbers for what we don't have. All right. And what radians we want to make sure that we got. Which key numbers, key points, right? We want to make sure we got right. Which two we haven't plotted yet. Let me say it that way.
4 pi and 12 pi.
4 pi and 12 pi. Let's plug it in. Why not? And plug this in. So that's -2 sine of x over 8 until we get the gist of what we're doing, and then we are going to probably use some more shortcuts. All right, f of 4 pi will equal -2 times sine of 4 pi over 8. So instead of putting the x, I'm replacing the x with 4 pi. How do you reduce 4 pi over 8? Anyone?
Pi over 2.
All right. Nice. 4 pi over 8 equals -2 times sine, said pi over 2. So that's -2 times, what's sine of pi over 2?
1.
1. -2 times 1 is
It's
-2.
0.
Uh-oh. The y value, right? I know cosine, kind of what I kind of think of C comes before S. Like X comes before Y. So Y associated with the Y. So that would be 4 pi -2. If we went ahead and plotted that, that's down here. Normally it's up here. But because of this reflection across the x-axis, whenever there's a negative in the front, that's going to flip things over. All right, let's try. You know what? No, let's go ahead and do it together. -2 sine of 12 pi over 8 equals to -2 sine. What is 12 pi over 8 reduced?
Three pi over 2.
3 pi over 2. Okay. And what is, so we got -2 times, what's sine of 3 pi over 2?
-1.
So -2 times -1 is +2. So that's why our point is up here for 12 pi.